Hello, class. I want to talk to you about how do you figure out how many valence electrons an atom has. And in this case, we're talking about a neutral atom. In the near future, we'll talk about ions, which have positive or negative charges. Okay, so this is for a neutral atom. Okay, so from the reading, you should have learned that the rows, as they go across, the rows, they are referred to as periods, okay? And they tell you how many shells an atom has around it, okay? So like hydrogen and helium, being in the first row, the first period, have one shell around it. And remember that first shell can only hold 2 electrons. Anything in the second row, so like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, have 2 shells around it, okay? And so it has, the first shell, which contains the core electrons, and the second shell, which contain the valence electrons. And anything in the third row has 3 shells around it. Okay. Now, once we get past the third row, it gets a little bit more complicated because now you've added in these transition metals here in the middle. For this discussion, we're going to act like they're not there. And if we look at elements in the fourth row, like this potassium, this calcium, and then skip the transition metals and go to over here to gallium, germanium, arsenic, selenium, bromine, krypton, okay, they have, for the purposes of this discussion, 4 electron shells around it, okay? And just so we know, as we look at these columns, okay, they are also referred to as groups. And sometimes they're numbered as they're numbered here, where they just go 1, 2, 3, 4, 5, 6, all the way to 18. But sometimes they're numbered where they're called 1A, 2A, and again, they'll skip the transition metals and start over here and call this 3A, 4A, 5A, 6A, 7A, 8A. And then they'll call the transition metals in the middle, they'll call them B, 1B, 2B. So either way, this numbering will help us determine the number of electrons, okay? If it's the numbering system you're seeing here, like where it's 13, 14, we just got to look at the ones place, okay? The 3, the 4, the 5, the 6, the 7. If it's labeled 3A, 4A, 5A, 6A, 7A, 8A, then you already have it. It's 3, 4, 5, 6, 7. Okay, so what do I mean by that? So to determine the number of valence electrons for an atom, again, we just have to look at which column it's in, okay? What column? So that first column, all the elements in this first column, in the first group, have 1 valence electron. And I'm just going to use the E, okay? All the elements in the second column have 2 valence electrons, okay? And again, we're going to skip over the transition metals, and all the columns in group 13, or 3A, have 3 valence electrons. The groups in 14, or 4A, have 4 valence electrons. This group has 5 valence electrons. This group has 6, and so forth. 7. And the noble gases, the last column has 8 valence electrons. Okay, and so again, for instance, let's say you're talking about calcium, and I want to know how many valence electrons there are. Well, you just say, okay, well, calcium's in that second column. It must have 2 valence electrons. Okay, let's say something like argon, okay, over here. Argon's in that last column. If we look at the top, that's 18, so we can look at the ones place, or it might say 8A, 8 valence electrons, okay? Let's look at like aluminum here, okay? Again, it's 1, 2, 3 over, it has 3 valence electrons. Let's even look at something like, let's look at bromine here, okay? Again, we go 1, 2, again, skip the transition metals, 3, 4, 5, 6, 7 valence electrons for bromine, okay? This is going to be very important for the next couple topics we cover, because you're going to have to do Lewis structures, in which the first step is figuring out how many valence electrons do you have between the atoms making up your molecules, okay? And then when we talk about ions, we'll talk about how molecules can lose or gain electrons. And so that will change it from this method, okay? But again, we'll talk about that in the near future. All right, I hope that helps.